Hi, everyone. This is Jim Cahill with another Emerson Automation Experts podcast. We continue our Asia Pacific Sustainability and Decarbonization podcast series with a closer look at the fast-growing biofuels and biomaterials sector, as it has a growing role in the energy and chemical mix in the region. I'm joined today by Emerson's Sanjay Thakker to discuss all about biofuels and biochemicals. Sanjay, thank you for joining us today.
Hello, Jim. Thank you for inviting me to be a part of the show.
Well, it's just great to have you here with us today. Well, let's get started by asking you to tell our listeners a little bit about your background and how you got to where you are now with us at Emerson.
Thanks, Jim. Well, I completed my bachelor's degree in instrumentation from India in the year 1991. And post-graduation, I joined India's leading fuel manufacturer and retailer, Indian Oil Corporation. Worked here for more than 2 decades in various roles in refining and petrochemical operations. So, Jim, if we see the initial refineries were very simple in configuration, but yes, big energy guzzlers and highly polluting. So it was only in mid-90s, typically in India, we see that environmental concerns were coming up and a lot of new fuel quality upgradation units were being added. Natural gas was added as fuel to really reduce the emissions. But yes, it improved the refinery operations, but it added another problem. Now, petrochemicals was also coming up, and all the refineries were going for petrochemical production, which was finding increased application in all industry. So these polymers and the petrochemicals and the polymer units were really polluting industries. I had worked there. I know how it is. And after working for so many years in fossil fuel related industry, I can appreciate the tremendous impact what this biofuels, which we are going to talk today, and the materials, which is going to really make in the time to come, that will become a significant portion of our energy usage in the times to come. Globally, also, we see that all the leading industries really focusing, all are focusing on sustainability and decarbonization. So when I joined Emerson in 2019 to support refining and petrochemical business in India, so it all started that Emerson also is now a committed company to global S&D efforts. And I am supporting the sustainability and decarbonization business for Emerson Automation in the Asia Pacific region for a natural choice, which is biofuels and biomaterials. So you can say that my role aligns well with my passion in the energy space and Emerson's purpose to help customers make measurable progress towards their net zero targets.
Well, yeah, it sounds like that background you have makes you fit in just perfectly for that role. So let's get into it today. So we're talking about biofuels and biomaterials, and there seems to be a lot of talk about changing the global energy mix and circular economy. Since we are talking about wide-ranging industry applications, perhaps you can start our discussion off first with biofuels, just by explaining what biofuels are.
Sure, Jim. In simple terms, if we see, biofuel is something which is just not derived from fossil fuels and rather produced from biomass. Now we see that biomass can be used as fuel directly. We have seen since ages like wooden logs, burning of wooden logs produces energy. So some people, yes, use biomass and biofuel interchangeably. But what we are going to talk today in industry parlance is the biofuel which we are referring to, the liquid or gaseous fuels, which we can use for transportation or other industry usage. Now, typically, biofuel can be produced from agricultural, domestic, or any industrial bio waste. But we see the industry today, which we talk about, the most common liquid biofuels in the industry we see today are bioethanol and biodiesel. Yes, industry is talking about renewable heating oil, renewable jet oil, or we call it sustainable aviation fuel, and other emerging biofuels that are still in various stages of development and commercialization. When we talk of the gaseous fuels, it is something which we are looking for an alternative to natural gas. So basically, we deploy waste or biomass sources like agricultural residue, sugarcane press mud, or any kind of solid waste like municipal waste or sewage treatment plant. It all helps us and gives us in producing biogas through the process of anaerobic decomposition. Now, the gas which is produced, the biogas which is coming, it's not pure. It has got a lot of impurities and cannot replace just like that in natural gas. So what we do is we remove the impurities like hydrogen sulfide or the carbon dioxide or the water vapors. And finally, it is compressed so that it can be really injected into the natural gas pool. So today, yes, if we talk about the bioenergy, we have the liquid energy in the form of liquid fuels, biofuels, and second is the gaseous forms. We call it compressed biogas. We call it CNG. We call it RNG. It's the same, but a replacement, a healthier replace, or a, I will say, more sustainable replacement of natural gas.
Well, that's a great overall picture of defining what we're talking about with biofuels. So it's all about waste to energy. These days, we hear a lot of noise about bioethanol, biodiesel, etc. Can you tell us a little more about these?
Sure, Jim. Let's talk about these next gen fuels. Bioethanol, which is a renewable fuel and can be made from various plant materials. Now, most ethanol is made from plant starches and sugars, but technologies today allow for the use of cellulose and hemicellulose, which is nothing but a non edible fibrous material that constitutes the bulk of plant matter. And we will see how various companies are deploying these new age technologies. I mean, the most common method for converting biomass into ethanol is called fermentation. Now, during fermentation, the microorganisms like bacteria, they metabolize the plant sugars and produce ethanol. And this ethanol is basically used as a blending agent with gasoline to increase the octane and cut carbon monoxide and other smog causing emissions. The most common blend of ethanol may be referred as E10, E15, or E20. If we hear these numbers, but this is nothing but a percentage which is referring to the percentage of ethanol which is added in petrogasoline. For example, when we say E10, it refers to 10% ethanol and 90% gasoline. Some countries like India are moving towards even E20, and these newer vehicles are being developed nowadays called flexible fuel vehicles, which can take even higher blend of ethylene. When we talk of biodiesel again, it's a liquid fuel again produced from renewable sources such as new or used vegetable oils or animal fats, and is a cleaner burning replacement for petroleum based diesel fuel. Now, when we say petroleum derived diesel, then biodiesel is used to fuel the same compression ignition diesel engines. It can be blended with petroleum diesel in any percentage depending on geography, the seasons, the heat and the cold weather conditions, and the applications we are going for. So while the most common blend which we see in the most countries is B20, which contains 20% biodiesel and 20% petroleum diesel. Maximum, yes, we do hear of Indonesia moving to B40 blends. Other fuels I would like to touch here, Jim, are which are now gaining importance, even the sustainable aviation fuels, SAFs, which are jet fuels, which are certified for use in even commercial jet craft and meet that greenhouse emissions and other sustainability criteria. These are also made from raw materials other than fossil fuels. So if we sum up and we see the global scenario, USA is the largest producer of bioethanol, while European Union is the largest producer of biodiesel and RNG. But AP is fast catching up, and large capacities are being set up for domestic consumption as well as for export to Europe and USA. As per IEA estimates, Asian biofuel production may surpass that of Europe by 2026.
Wow, that's some incredible growth there for those fuels. So, Sanjay, I hear the terms biodiesel and renewable diesel, and they seem to be used interchangeably. Can you tell us something more about these two?
Yes, Jim, that's a very interesting question, and people are often get, I will say, confused between renewable diesel, biodiesel. Let's understand the difference between renewable diesel, which is also known as R99 commercially, which is also biodiesel, and there is a biodiesel called fatty acid methyl ester or FAME, FAME. Both are and renewable diesel R99, sometimes it is also referred to as hydrogenated vegetable oil, HVO. Both can be blended with diesel fuel, while renewable diesel has the same chemical composition as fossil diesel and so is fully compatible with existing diesel engines. Now the biodiesel or a FAME, which has got a different chemical composition as compared to fossil diesel, and so for the existing engine or the existing diesel engines, it is a limited blending which can be done without doing any modification to the engine. So, say typically Europe limits the blends to 7% for the existing engines. While both can be made from the same organic waste streams, the difference comes from the how it is manufactured or how it is produced. The biodiesel or the FAME is made through chemical process called trans-esterification. This process converts the biomass oils into fatty acid methyl esters and glycerine. On the other hand, renewable diesel is chemically made through hydroprocessing or hydrotreating, where the hydrogen is deployed using under high temperature and pressure, same as petroleum diesel nowadays we are producing. So basically, the how it is produced, the method of production is creating this difference. And biodiesel is generally referred to a blend than a complete traditional fuel. The way ethanol is blended with gasoline, biodiesel is blended with petrodiesel. It's there to help us in reducing fossil fuel content and therefore reducing carbon emission.
Well, that's interesting, the differences in those two, that the biodiesel really is a blend and you got to keep it somewhat limited, where renewable diesel is fully compatible, or it's basically a replacement for petroleum derived diesel. That's very interesting. So, can we use any available renewable or biodiesel in our current vehicles without any modification in the engines, or are there challenges in large scale adoption of biodiesel?
Yes, Jim. We will have to deep dive more into this. So, when we talk of renewable diesel, it is for all intent and purpose. It's a pure diesel fuel. It has got the same chemical properties as petrodiesel. It functions identical to the fossil fuel with lower carbon emissions and environmental impacts. And and yes, without any deterioration in performance or the maintenance requirements. So renewable diesel greatly improves greenhouse gas emissions by, it says that up to by 75% it can improve, while retaining all the power of standard petrodiesel. The carbon intensity of renewable diesel is approximately 60% less than petroleum diesel. On the other hand, when we try to use biodiesel, yes, we do face some challenges in terms of can it be used in the existing engines, and under what conditions it can be used? What are the storage conditions? So yes, biodiesel, the limitation is the main limitation comes from the right temperature range. It needs to be stored at a right temperature range. It cannot be used in cold weather conditions, or if it is too warm also, it could grow mold, and if it's too cold, it may gel up. So biodiesel has got some limitations when we are deploying it for the diesel existing diesel engines, and people have reported uh, the more frequent replacement of fuel filters. So in terms of maintenance, also it increases some maintenance cost. In technical terms, when we see biodiesel, yes, it both CTIN number as well as the cloud points are compromised to some extent in biodiesel. But yes, both to sum up, both fuels are made from similar materials. The difference comes from how they are manufactured. Both helps in reducing greenhouse gas emissions, and government policies are the prime driver of the growing production capacities, I can say.
So you mentioned governments are recognizing the potential for biofuels. Can you elaborate on what countries in Asia are communicating their strategies for biofuels, and how is Emerson helping these countries meet their goals?
Perfect, Jim. You are touching a very relevant point here. So, these improved policies and the COP26 climate goals are set to propel renewable fuels growth to greater heights. The government mandates, the incentives, the standards are all basically to lower the carbon intensity of the fuel. And the consumers are also asking for meaningful action on climate change. And all these are acting towards increasing the demand for biofuels. IEA estimates suggest that Asia will account for almost 30% of the new production capacities which are coming up in next 5 years. This is mainly due to the strong domestic policies, growing liquid fuel demand, and export driven production. Everything is really driving the demand. If we see recent Indian ethanol policies and blending targets for biodiesel in Indonesia and Malaysia are all responsible for most of the growth in Asia. India is set to become the third largest market for ethanol demand worldwide by 2026. China's plans to peak emissions before 2030 is leading to vigorously promote alternatives like advanced liquid biofuels and SAF, and will play an important role in achieving emission reductions in China. Another driving point to changing global energy mix is the post corona world order and the new emerging geopolitical equations, largely due to the conflict in Europe, driving governments working on reduced dependence on fossil fuels, which are largely controlled by a handful of countries. Added to this, record high prices of fossil fuels are helping in making renewable fuels more viable. Within Asia, if we look, due to the huge push by government of India, India is emerging as hub for bioethanol and biogas. Recently, a national oil company, Numaligarh Refinery, has joined hands with two Finnish companies, Messrs. Fortum and Messrs. Campolis, to make a strategic into the field of producing ethanol from cellulosic feedstock called bamboo, which is available in abundance locally. Now, this refinery is not just bioethanol, it's a biorefinery and producing chemicals also like acetic acid, furfural, and furfural alcohol. And I'm proud to share that Emerson is the lead technology supplier for India's first cellulosic feedstock based biorefinery. I will give you another example, which is where Indian Oil is setting up a compressed biogas or natural renewable natural gas plant. All these national oil companies in India are establishing more than 3,000 renewable gas plants and are promoting private sector investment with assured buyback of products. Another example is Neste of Singapore, which has become a hub of renewable production. Neste's renewable and circular solutions are produced by renewable raw materials. The majority are waste and residues, which are used as cooking oils and waste animal fat. To summarize, major AP countries have demonstrated an understanding of the current situation and opportunity it provides of shifting global energy transition and aligning their strategies around the same.
Well, Sanjay, that's a great overview of some of the things that are going on in different parts of the Asia region. It's clear from what you outlined that biofuels is going to assume significant importance in changing the energy mix going forward. Tell us something about changing biochemicals or biomaterials, and what opportunities and challenges are you seeing in the Asia Pacific region?
Yes, Jim. Let's focus on biochemicals, which presents another exciting opportunity to replace fossil fuels. Given the tremendous focus we are seeing on actions to mitigate climate change, steps are being taken to move away from today's fossil based economy to a more sustainable economy based on renewable materials and recycling. Again, the main driver for the entire circular economy is the global issue of climate change and the need to reduce greenhouse emissions. The desire of many countries to reduce an over dependency on fossil fuel imports by diversifying their energy sources is another reason driving the need to develop an environmentally, economically, and socially sustainable circular global economy. To become truly sustainable and circular, industry is increasingly viewing chemical and polymer production from renewable sources as well as chemical recycling as the future modus operandi. Plastics have become an integral part of the economy where we really need to focus in terms of converting them into biodegradable plastics. Industry is working on both biodegradable plastics from fossil based chemicals as well as renewable sources. So, what I'm trying to say here is that we can make biodegradable plastics from fossil based things as well as from renewable sources. Within Asia, China is setting up large capacities to produce plastics which are biodegradable in nature from fossil fused bale resources like PBAT, which is mainly derived from esterification and polycondensation of BDO, PTA, and AA, which is adipic acid. Again, I'm happy to share that Emerson is associated with Inner Mongolia, Dongguan, Huangfeng, and Junzheng project for the new PBAT capacities which are coming up in China. Thailand is making another progress in renewable bio-based plastics. Most notably here, cassava and sugarcane, which are available abundantly locally. As it contains glucose, sugarcane is highly useful raw ingredient for bio-based products. As opposed to other starch-based feedstock, glucose requires no additional processing before use in biochemical and bioplastic production, and it can help us in shortening the conversion process and decreasing the production cost. In Thailand, Purac from Corbion Purac is producing lactic acid, which is most vital biochemical for bioplastic energy production. Total Carbion is another company which is focusing on polylactic polymer PLA, another bioplastic material. To sum up, both fossil based as well as renewable material based bioplastics are gaining significance in Asia Pacific. Another important aspect which I would like to highlight here is the plastics recycling, where Pure Cycle and Mura Technology are key technology providers. Within Asia, if we see both Japan and Korea are setting up facilities for plastics recycling. Emerson is official partner for Bond Digital Smart program with Pure Cycle Technology USA. So yes, several challenges do exist, Jim, but with all of them, solutions are being developed. And here at Emerson, we certainly see ourselves as partners to finding solutions to overcome them and make this world more sustainable.
Well, Sanjay, this has been a fascinating discussion and really eye-opening with what's going on across the Asia Pacific region. It sounds like a whole bunch and even more to come. Well, I want to thank you so much for joining us and sharing your expertise with our listeners. And I'll add some links in the transcript and here at the end to the renewable biofuels section and the sustainability and decarbonization sections on emerson.com, as well as the contact details for sustainability and decarbonization experts in the Asia Pacific region. So again, Sanjay, thank you so much.
Thank you, Jim. Thank you for having me here.